Good morning, my friends. So for today's science lesson, we're going to be talking about sound. So sound is everything that you can hear around you. Let's stop and listen for a second and listen to anything that you can hear and write that down on your worksheet. So pause the video here to do that. So like light that we learned about last week, sound is also really important to help us communicate. I'm communicating with sound to you guys right now. I'm also using light through my video so you guys can see me, but I'm mainly using my voice and sound to communicate with you. Sound can also help us tell if there's help coming, like if you hear a siren from an ambulance or a fire truck. It can also tell us if the ice cream truck is coming, if you hear the song from the ice cream truck. But yeah, people and animals also use sound to communicate. For example, cows can moo when they're hungry to let people know that they're ready to eat, or dogs can bark if they're scared or threatened or having a good time. Tons and tons of animals and people all use sound to communicate. Sound is another form of energy. We talked about energy last time. So just to remind you, energy is the power to do work. You need energy to play, you need energy to talk, you even need energy to learn this lesson about sound. Sound is energy that you can hear, but those sounds run out of energy over time, which is why you can't hear someone talking at a normal volume from really far away. You have to get closer because those sound waves don't have enough energy to reach you if you're too far away. That sound energy is created when objects vibrate. To vibrate is to move back and forth really, really quickly. Like some of you know that a phone vibrates. That's just a mechanism inside the phone moving back and forth really, really quickly to make the whole thing shake. A little mini experiment you can try to hear or to feel something vibrate is if you talk and you put your hand on your throat, you can feel the vocal cords inside your throat vibrating, and that's what's creating the sound. So like light that we talked about last week, this sound energy also travels in waves. So those waves are created when an object vibrates and it shakes the particles in the air around it, and those particles carry the sound. So kind of like a relay race runner who has the baton, if the baton was the sound. So when that runner starts running, he's carrying the sound with him and then he hands it off to the next runner. That would be the next particle of air, or particle of water, or whatever that sound is traveling through. They'll get the baton and they'll go and they'll carry it to somebody else, and then they'll get it and they'll carry it, and that's how those sound waves travel. So it really looks like a ripple on the water if you were to throw a rock into a pond of water. When those waves go out, that's what the sound waves looks like. They travel in a circle, expanding out from where that rock hit or where the sound was generated. And because sound is just created by vibrations, sound can travel through all sorts of different materials. It can travel through air, it can travel through water, it can even travel through solid objects like walls. Okay, so to do this next experiment, this is going to be called our sound wave xylophone. So what you're going to need is at least 2 glasses with water in them of different amounts. So I have 1 glass that's empty, 1 glass that has about a quarter full of water, 1 glass that has half full of water, and then 1 glass that's mostly full of water. You're also going to need a pencil or a pen or something of that nature to tap the sides of the glasses. So then what we're going to do for our experiment, actually before we get to our experiment, I want you guys to pause the video here and make some prediction as to what you think is going to happen in this experiment. All right, great. Now that you guys have made your predictions, we're going to get to the actual experiment. So for this experiment, what you're going to do is you're just going to tap the side of the glass with your pen or your pencil and listen really carefully to what sound it makes. All right. Do you guys notice anything different about those sounds? So If you're having trouble hearing it, you can take out, if you have more than 2 glasses, the 2 with the closest sounds, and just do the 2 with the most different amounts of water in them. So I have my empty glass and I have my full glass. So I'm gonna try that again to see if you guys can hear the difference. All right. So if you couldn't hear that on my video, maybe you can hear it a little bit better at home. But basically what's happening here is, remember how we talked about how sound is a vibration. So it goes off in waves. So when we tap our glass, we're vibrating the glass, and that's sending the sound out in waves. And then when that sound reaches our ear, we're gonna hear that sound. But if we put water in our glass, it's causing that vibration to, it's causing that wave to have less energy. In that water is absorbing some of that vibration, so we don't hear as loud or as high-pitched of a sound coming from the glass with the most water in it. And as we go further down in our amounts of water, that wave is going to get more and more energy, so that sound is going to be a little bit louder and a little bit more high pitch. So now that we've finished our experiment, just make sure you fill in that portion of your worksheet that tells you what you actually saw in the experiment and if your prediction was true or not. So that's it for this week's video on sound. Remember to fill out your worksheet with the vocabulary terms, the predictions from the experiment and the results of that experiment, and any other questions that are on that worksheet. Thanks, and I'll see you guys next week.